Bismillah ar-Rahman ar-Rahim, in the name of Allah, the most gracious, the most merciful. Now, inshallah, we will begin recording. As we agreed together, we begin recording after answering your questions or revising any points of the previous lecture, okay, to shorten the video as possible as it. Today, inshallah, Rabbil Alameen, we will talk about this point, which is measuring mass. We finished measuring length, measuring volume, and now we will talk about measuring mass. Before talking about measuring mass, let me remind you that in physics, we have a very famous quantity that we will talk about it today, inshallah. This famous quantity is called density. We will talk about it, inshallah, today. It's called what? Density. And this density has the symbol rho. This letter rho is written like this. Okay? This density equals mass divided by volume. And last period, we learned together how to measure the volume. So we measured it last period. This period, we will be able, inshallah, to measure the mass. So it's expected directly to explain the density after finishing determining or measuring mass. Because I say that what? Because after finishing the mass, I'll go directly to the density, inshallah, Rabbil Alameen. Although it exists in your book, close to the end of the topic 1. But why did I bring it here or explain it here? Because it's related here. I measured the mass, then measured the volume, okay? And they are present in my mind. So when I tell you that the experiment that you have to make or perform to measure the density, they will be present in your mind, okay? This is a very important point to know. Why did we explain this now? Let's go. So here, we will learn to measure mass. طبعا, we know that measuring mass can be done by devices called balances. Okay, balances. Right. We have two main types of balance. One is the classical one. It's the famous shape of balance with two pans. Okay, and this is called beam balance. Okay, so this kind, which is beam balance, in it, the unknown mass is placed in one pan and is balanced against another known mass in the other pan. I think this idea is so clear. Okay, so if anyone doesn't understand this point or need more clarification, please raise your hands. Well, now let's go to the second kind, which is called the lever balance. What's meant by the lever? The lever is an arm, something like an arm. Okay, this arm is rotating around an axe called a pivot. Okay, so the lever and are pivoted. We have a set of them or system of levers. They act against the mass that we want to measure, and after, they give me, without more details, those are out of our syllabus, okay? They give us the final reading of the mass either on a scale by a point that moves in front of a scale, or on a screen as a digital reading. Okay, this is the lever balance. Let's see the shape of the lever balance. This is the shape of this one. This one called the traditional scale. Okay, traditional scale. You know the scale is the balance, especially that the balance with one pad. Okay, so the balance that you are sending on it to see your weight, okay, or to see your mass in malls and pharmacies and so on. This is called bathroom scales. Okay, so the scale is a kind of balances. Okay, so this is the arm, but this is it takes the reading, the lever of the balance. It takes the reading using as a pointer that's rotating on a scale, as you see. Okay, so it may be called the analog one. Okay, sometimes instead of this unit or this scale, there is a screen. Okay, with that gives you the reading directly as numbers like this. Okay, digital. Okay, well, so these are the types of balances. Now we finished the measuring balance. Okay, Ashraf, Yusuf Ashraf is want to ask a question. Fadal.
Mr. I did not understand the lever balance. Please, if you can.
شوف, the idea what's happening inside the balance, it's not in our syllabus. بالمرة. احنا عندنا هي عبارة it's a set of levers. Okay, these set of levers لما بنحط البالانس بيدوني reading. لما بحط الماس بيدوني reading. ده كل اللي انا عايز اعرفه عنه.
Okay, thank you.
وصلت ولا؟ طيب. So here now let's check this question together. So easy, direct question. Okay, which instrument is used to compare the masses of objects? I'll choose, let's choose, for example, Muhammad Ahmed. I unmute you. Muhammad Ahmed. Okay. تفضل. Muhammad. يا جماعة, according to the rules of the school, the new rules or the new instructions, anyone who will be called by the teacher 3 times, 3 successive times, okay, if he doesn't give any response, it means he is not in the period. Okay, he suspended his name and he goes away to sleep, for example. So he immediately will be removed. So even if you don't know, tell me, Mr. I don't know. I re-explain to you. But don't say like a piece of stone or rock. Muhammad Ahmed. This is the second call. Muhammad Ahmed, I unmuted you again.
Sorry, Mr. I had to do something.
Okay. You don't know يا Muhammad, or you want to answer?
No, I want to answer.
تفضل.
Which instrument is used to compare the mass of an object? D.
طيب. Concentrate the mass. The masses.
Yes.
Measuring cylinder there, Muhammad, is used for what? For measuring what? Volume. It's used for measuring volume. مالوش دعوه بالماسد ابدا. اوكي؟
Okay.
مين بقى بيقيس الماسد؟ What measures masses? The balance. The balance. Concentrate يا محمد please in your favor. احنا بنعمل الكلام ده عشان ما تسرحش حبيبي. خلاص؟ انا ما عنديش مشكله انك تسرح جدا، بس لو سرحت اللحظه raise your hand. Mr. Again please. حاولك عينيا الاثنين. اوكي؟
Okay.
Thank you يا محمد. The next question. This is not question, it's an experimental note. Measuring mass of a liquid. If I ask you, how can you measure mass of a liquid? I think it will be so funny, and I can consider it just for kidding if you say we will put the liquid in the pan, because sometimes even the pan is flat, like this case. And you have electronic device, yani you want to make a musiba. Okay? So what will we do in this case? We need a container. But this container has a mass, mister. So it will give me a wrong reading. Yes. So we will balance, we will put the empty container, which is measuring cylinder, on the balance and take its reading to know what is its mass. Then we will pour the liquid to be measured in this container, okay, and see the new mass, because the new mass is the mass of the liquid and the container or the measuring cylinder together. Then we will subtract them, because the difference is the mass of the liquid, the mass of the liquid. Okay, I'm sorry, I'll lower hands. Please, everyone, lower your hand. Lower your hand, please. I'll tell you why. Lower hands, please. Only the one who didn't understand what I said, raise your hand. Only the one who didn't understand what I said now, raise your hand. طيب، اتفضل محمد صلاح. What's the problem with you? محمد صلاح and يوسف شهاب.
يا باشا ما فهمتش أول جزء.
طيب، okay. يوسف شهاب، خلاص lower hand. Thank you محمد. يوسف شهاب. اتفضل. Ask a question. You don't understand only or anything else? If the point is that you don't understand, please lower your hand. Yusuf Shihab and Yusuf Osama. Because I will explain it now. Anyone wants me to re-explain this point now? Lower your hand. خلاص, I got your question. طيب. What's your question, Yusuf? تفضل.
Mr. How to measure the mass? First we measure the container, then we measure with the liquid, then we subtract them.
تمام. Yusuf Osama, your question.
Mr. The question is not about the mass of the liquid, it's about the general mass. So we use a balance to measure the mass. But then if we use a balance, we are measuring the weight, because
not any balance measure.
The balance works with gravity.
لا. Weight is for gravity. But the balance is undergoes we make to the balance some process called standardization. Standardization. This standardization measures what? Changes the scale to read masses directly. We have another kind of balances called Newtonometer or Newton meters. This measures the weight directly. You get the idea?
Yes.
تمام؟ لكن هو depends on the gravity. مظبوط. هو in fact, by the way, the balance doesn't measure the mass, it measures the weight. But it's standardized. يعني احنا بنعمل السكيل of the balance, okay? to measure the gravity direction, the mass direct. Okay? Is it
Okay.
clear?
Yes, it's clear.
So here, in this case, measuring the mass of liquid. Because the balance يا جماعة أصلا the balance is يعني the main idea of the balance or the early idea of the balance is to compare between masses. This is the main idea. Okay? So يعني I don't want to talk about any details that may make you confused because they are out of our syllabus. Okay? لكن ممكن later يعني نبقى نعمل حصة نتكلم فيها عن شوية details يعني. Okay. So now here in this case again I'll re-explain. I want to determine the mass of liquid. What's the difficulty? The difficulty is you cannot put the mass, the liquid, on the balance directly with no container. So we will use a container, which is the measuring cylinder. Okay? We will put the measuring cylinder, which when it's empty, on the balance and take the reading. So this reading that I had now, okay, this reading now is M1, which is the mass of the balance only. So the mass of the measuring cylinder only when it's empty. Okay. Then I'll pour water in the measuring cylinder. Then I'll measure. I'll take the reading 2, which is the liquid and the balance and the cylinder together. Okay. So if I want to find the mass of water, it will be M2 minus M1. M2 is the cylinder only. M1 is the cylinder only. M2 is the cylinder and water together. You got the idea? You got the idea? طيب يبقى الحمد لله كده ايه اتضحت الفكره. طيب let's apply Sebastian tell me Sebastian,
Yes,
I ask you to tell me in the light of what I explained a few minutes ago, what will the reading, the mass of the water here will be? What will it be? Look at the figure well. These units are in gram. 50, 70 are in grams.
You say that we will make M2 minus M1.
Yeah.
It will be 20.
Yeah. So the mass.
And the unit.
20 gram. Yes. Excellent answer. So the mass of water here equals 70 minus
50
equals 20 grams. Okay.
Mr. We write the unit or no?
Oh, you have to write the unit. تمام? Okay. تمام. So here, alhamdulillah, we finished this part and it's piece of cake as we see. Now, as I told you, we will jump to the density. Okay. What is the density? Density, we can say it's the mass per unit volume. Well, this is not accurate, but it's not wrong. Okay. So the density is the mass per unit volume. But because density is different from the mass, density is different from the mass. So it's not good to say the density is the mass. So we say the density It measures the mass per unit volume. Okay, well. So, Mr. What's meant by this word, unit volume? Unit volume means volume equal 1. 1 what? 1 unit. Any unit you want to use. The most important thing is talk about 1. 1 unit volume. 1 meter cubic, 1 centimeters cubic, 1 liter, as you want. So the density is the mass per unit volume. The density is the mass per unit volume, or we can say it's the mass of unit volume. So for example, if I want to determine the density of water, I'll bring 1 liter of water, or 1 centimeters cubic, or 1 meters cubic. This is meters cubic, huh? This is cubic square, or 1 meter cubic. Okay, then I'll determine its mass. The mass of 1 volume, 1 unit volume, will be equal to the density. According to that, the density equals the mass divided by volume, the mass divided by volume, and we can say that the mass divided by volume, the density has the symbol rho, if you remember. This is called rho. Rho, it's a Greek letter, it's not P, yeah? It's not P. So here, this is not P. It's rho, 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 okay? It's a Greek letter corresponding to the letter R in English, okay? So here, in this case, I can say rho, which is the density, equal m, which is the mass, divided by v, which is the volume. And I can make this triangle or pyramid, okay? M is here, rho is here, and V is here. Well, what are the factors affecting density? First of all, let's talk about the measuring unit of the density. The measuring unit of the density is the mass is measured in kilograms or grams. The density is measured in cubic meter or liter, okay? So the SI unit is kilogram cubic per cubic meter, okay? But I can say, Mr. gram per liter, yes. Gram per cubic centimeter, yes, you have no problem. But if I ask you what is the SI, you have to say the SI, nothing else. Well, so what are the factors affecting the density? Number 1, the kind of material. Number 2, the temperature. These are the factors. Someone may say, no, mister, the factors are expected to be mass and volume because we get the factors from the formula. Yes, but not always. Almost, not always. Okay. Why? Imagine that. If I tell you that the density of water is 1 gram per cubic centimeter, and this number is correct at 4 degrees Celsius, or in 4 degrees Celsius. Now, if I have a drop of water, what is its density? It's 1 gram per cubic centimeter. If I had a container of water, what is its density? It's 1 gram per cubic centimeter. So this is water and this is water. Some guy may say, no, mister, how can you say that? The mass of the drop is small, but the mass of the container is too large. So how can you say they have the same density? The density is mass over volume. I can answer him saying that, yes, the mass of the drop is too small, but its volume also is too small. So when you divide them over each other, they will give you the density, which is equal to the same result as if you divide the large mass divided its volume, which is large also. So we almost say what? We almost say the density of water, the density of copper, the density of iron. We don't say the density of the object. We can say, and sometimes we say that expression, but in limited cases. But generally, we relate that density to what? To the material, not to the body. طبعا we can relate it to the body, but the most common is relating it to the material. Okay, so it's dependent on material. So let me show you this question. طيب الأول نخلص temperature. As temperature increases, concentrate well. Because this is a very important point. As temperature increases, what will happen to the volume? The volume is increasing also. Why? Because it expands. But here, the volume expands, but what happened to the mass when the object expands? The mass stays the same. Okay, expansion doesn't affect mass. So here, what will happen to the density? It decreases. So as temperature increases, the volume increases and the density increases. So this is the effect of temperature. Okay, so let's clear the drawing. Or before clearing the drawing, let me listen to your questions. تفضل يا يوسف أشرف. Okay,
Sir, hello. I did not understand the kind of material, the factors.
Here in the factors, kind of material means what? يعني for example, if I have, خليني أوري لك سؤال. Okay, look at this. Here, this question. 2 cylinders are made of the same material. Okay, 2 cylinders are made of the same material. Let's create a drawing. Okay, both cylinders have the same cross-sectional area, but one is longer than, not this. ماشي. One, لا هي this. One is longer than with the same, they have same cross-sectional area, but one is longer than the other. يلا بينا. Which quantity is the same for both cylinders? What is the key word here? The key word here is this: made of the same material. Same materials mean same density. Because the density is a specific property. It's related to the kind of material mainly. وصلت كده يا سيف؟
Mr. Thank you.
Welcome. Okay. طيب. نرجع تاني عشان الناس عايز تسأل على الدروينج اللي انا كاتبه ده. في ايه؟ انا ماشي الاوبوزيت دايركشن. يلا. اوكي. عبد الرحمن الخضري.
Yes, mister. I didn't understand the temperature.
Okay, عبد الرحمن. What does the temperature do? طبعا remember that the density equals mass divided by volume. Okay, so what does the temperature do? Does the temperature affect the mass? No, it doesn't affect the mass. طيب, does it affect the volume, عبد الرحمن?
Yes.
Yes, because it makes thermal expansion. Okay, so as temperature increases, the volume increases due to the thermal expansion. So as the volume increases, the volume here is the numerator or denominator?
The denominator.
The denominator. So the density, as the volume increases, the density decreases. So as volume increases, the density decreases. So if you remember, when we were studying the conventional currents, we said that the hot air moves up. Why? Because when it becomes hot, it expands. Then it has less density, so it moves up. Is it clear now?
Okay, thank you, Mr.
Welcome. Okay, so now let's go to this, which is a numerical example. Okay, this is just a numerical example. Okay, let's solve it fast because the time is to finish. Yalla. Here, the diagram shows a cuboid metal made from a metal of density. This is the density. Okay, so this is rho. Now, during reading the question, immediately once you see you see a given, write the given. So this is rho. Okay, what is the mass? He's asking about the mass. So where is the volume? I need volume to find rho equals m divided by v. So m equal rho times v. So where is the volume? The volume is given here. Yes, mister. So the volume equals 2 times 2 times 10 equals 40 centimeters cubic. Okay, so rho equal, so m equals rho times v, so it will be 40 times 2.5, so it will be 100 grams. So the answer here will be 100 grams. I think it's a piece of cake. Okay. Well, so we finished today, Alhamdulillah Rabbil Alameen. If you have any question, inshallah, by the way, I'll send you some questions today, inshallah, to solve them. Few number of questions on what we studied. They will be homework, inshallah.